Today I'd like to show you a motor I've designed to run on very low voltage. Right now it's running below 9.4 millivolts. And as you can see, there's very slow rotation. And I'd like to describe some of the details of the motor. First off, the CD you see is not used in any way except to give the Wendy's drink cup a nice stable base to sit on. There's a reed switch behind this little panel PC board, which came out of a computer printer, which actually turns the voltage on and off to the coils to drive the motor. I use 3 sewing machine bobbin forms to wind the coils on. There's one coil here, one over here, and another one in the back. The actual armature of the motor is the green part is a peanut butter jar lid, about 3.5 inches in diameter. The motor has 5 poles on it, these magnets, spaced around the outside of the armature. The axle shaft is from a DVD or a CD player. I'm not sure which. I've had it for quite a while. But the reason I'm using it is because the end of it has got a nice rounded point to it. It's not sharp, but it's a rounded point. The small ball bearing and the larger one are used because if the cup itself isn't absolutely vertical, then the motor, as it runs, the shaft would tend to run off to one side of the longer magnet here. So by using the ball bearings, that lets the motor hang vertical no matter if the cup is off one way or the other. Also, the small ball bearing presents very low friction to the axle because the diameter is so small that the contact point is much smaller. The longer magnet here is out of a pressure cleaner, like you'd clean your sidewalk with. And the main reason I use that is to get the armature low enough in the cup so there's room for it to fit in there with the magnets on the outside of it. Now, what holds all this assembly onto the cup is outside the cup there's a 1/2 inch flat disc magnet here. And then inside the cup at the very top of that bar magnet is another flat magnet. Mainly because these 2 magnets are stronger than the bar magnet, so they're supplying most of the magnetic force to hold the motor up. There's also an LED on the near the reed switch, which when I run it on higher voltage, that's used to tame down the back EMF so the reed switch doesn't get damaged by the voltage. And of course at this voltage there's no worry about that. What I'd like to do is show you that I'm actually running this motor on that low voltage. The red and black leads there are from the power supply, and I'm going to pan up to the voltmeter. And right now it's reading millivolts, so what you see is 9.4, 9.3 millivolts. The power supply varies a little bit as the motor draws the current. What I'm going to do is switch it to the 1 volt scale. There we go. And it reads 9 millivolts. So let me switch back so that we got the true reading. Okay, and some people might say, oh, he's hiding something behind that the white backdrop there. That's helping the motor run or whatever. And no, really what it's there is so that you can see the details of the motor. Because when I remove the backdrop, it gets pretty confusing with all the rest of the parts on the table. There's nothing back there that's helping the motor. It's just more stuff on my workbench. If you'd like more details on this motor and actually how to build it, go to my website. You'd see the link at the beginning and the end of the video, and you'll be able to get more details about the motor. And thank you very much for watching.